Good afternoon, good morning, good evening, depending on where you are getting us from Africa and across the globe. Welcome to this presentation where I dive into the solar PV system with the solar inverter as the heart of the system. I'll be looking at optimizing your residential solar PV system. I'll be looking at optimizing your residential solar PV system. So in the optimization of your solar PV system, we'll basically look at control, the solar PV stroke inverter control. So today we look at part 1 and more parts will be done. And the person giving you this presentation, I'm Dr. Enoch Mlenga. Dr. Enoch Mlenga. And below we can see a pictorial presentation of a solar PV inverter, which is a 10.2 kilowatt or 10,200 watts, which has got an MPPT maximum charging current of 180 amps, maximum PV input voltage of 500 volts DC, and of course the battery connection of 48 volts. So come with me as we look at this optimization problem. Further on here, I give you what you'd call system architecture illustration of a solar PV system or solar PV inverter system. So as we all know and as we understand is that the solar PV inverter with inbuilt charge controller is the heart of the system, which can connect solar panels, can connect the utility stroke grid or generator, and of course giving a variety or a host of appliances or a host of electrical rods. And also to support the system in a residential house or a residential setup, you need a battery storage. You need a battery storage, which conventionally is external to the inverter system, but nowadays you can also find an all-in-one that encompasses a solar PV inverter and also a battery embedded into one unit. And also in the architecture illustrations, here we see operation without battery connected and also operation with battery connected. So an inverter system, some of them can actually allow you to have a system operation without battery connected, but which means that this can only support you during the day when you have got solar PV production. Once solar PV production goes to zero, then you don't have an output. So what is solar PV inverter control? What is solar PV inverter control? So the solar PV inverter control is basically the modes of operation in which one, your inverter is able to receive input power, that is AC, either from your utility or any other source like a generator that normally supplies your day-to-day system. So this is shown in one. And also solar PV inverter control attributes to the charging capability or the charging aspect when it comes to the batteries. Either you charge from your utility source or you charge from your solar panel source, or you charge from both sources at the same time. Also, it gives you a chance to prioritize your output. For example, in this case, up as alluded earlier, you can actually have output entirely from your solar panels, or you can have output coming from your utility, or you can have an output coming from your battery. So how you control the different aspects of your inverter or your solar PV system to stay within the boundaries of optimum operation basically gives you what is your solar PV stroke inverter control. But then, of course, the control aspect will also enable you to stay within the boundaries of what you have. When it comes to your solar panels, it comes to your AC or utility input, when it comes to your battery connection, and also when it comes to the output to the roads. So you will have boundaries in which your system should operate. When you fail to be within these boundaries, you'd either lost your control, and in most cases, your system will not operate at optimum pertaining to your requirements. So the system boundaries basically determines your control philosophy. The system boundaries that you have of your inverter will basically determines the control philosophy that you have. So a philosophy is just a way of how you will manage and control the different aspects of your solar PV system. So to actually accomplish this, to develop your control strategy, what are the tools that are at your disposal? What are the tools that are at your disposal? Before I showed you an illustration of this is a type of solar PV inverter. So your strategy can only be built in your user manual. So your user manual basically gives you everything about a component that you have. For example, a manual or technical information of a panel will give you information for the panel. A user manual and technical information of an inverter will give you all the system's boundaries of your inverter. Similarly, for your battery, it also gives you the boundaries of the battery. But then the system integration all comes together encompassed in a solar PV inverter. So the strategy is actually built within a solar PV system. So if we go back to look at the architecture illustration. So for you to make the connection, you have AC in or AC input. You have AC output. You have battery connection. And you also have your PV connection. So all these connection illustration on the architecture gives you the power system or the power connection. And it's worth to mention that the power connection, almost everyone is able to make a power connection. because you just follow. You see, this is where I connect the panels. This is where I connect the input AC. This is where I connect my loads. This is where I connect the battery. And you can power the system. And of course, a system can work in certain cases. But in majority of the cases, that system is bound to fail unless you implement inverter control, you develop a control philosophy, and you are able to pick your control strategy based on the boundaries that make up your solar PV inverter. So the tool that you have at your disposal to develop your control strategy or to develop your control philosophy is basically the user manual of your solar PV inverter. So here I show you 3 tools that would be at my disposal. One is that of a 1 or 1.5 kilowatt inverter. The other manual depicts 3.6, 4.2, and 6.2 kilowatt inverter. And the third one I have is a user manual that depicts 8/10 kilowatt user manual. Of course, what I've shown you here are examples of the manuals that I'll use as we build the knowledge. But of course, there are a lot of brands of solar PV inverter that are there, and each solar PV inverter will have a user manual. And the user manual becomes your tool on which you control, you build your control strategy. But also the guide to build your control strategy also emanates from the system's requirements. What does the customer want to achieve? What do they want? For example, if we go back to the system architecture, what do they want? Do they want just to power the loads from solar or from utility? Do they want 100% solar? Do they want segmentation? Do they want a backup system? Do they want a system where if everything else fails, you have the genset coming in? So what the customer wants to achieve, or what you want to achieve, basically gives an input to your installer or your engineer or your technician or your technologist, who will determine your philosophy that you need and go into the tool to basically come up with different aspects that will help you to control your solar PV system to an optimal level or optimized level where it works highly efficient. So, what is the first level control strategy if we dive into a user manual? So if we look at an inverter, the first level control strategy that you have are the technical specifications. So the technical specifications gives you the first level control strategy. So as we can see here, we have technical specification for a 12 volts battery, 1 kilowatt hybrid inverter, a 24 volts battery, 1.5 kilowatt hybrid inverter. So immediately you are able to see that this inverter is a 12 volts for the 1K, or it is a 24 volts for a 1.5 kilowatt. Equally, if we look at this one, we see that this is 3.6, this is 4.2, this is 6.2. And 48 volts of 51.2, but ideally we call it a 48 volts system when it comes to 6.2, and then we have the 24 volts system for the 3.6 and 4.2. Similarly, when we look at the 8/10, it also gives us the maximum power that it can give on a normal load. The maximum power that it can give on normal load. So in this case, if you are using the 8,000 watts version, then it's 8,000 as the maximum. This is the maximum. If we look at this specification, they show that 3.6, 4.2, or 6.2. And if we come here, they show 1 kilowatt or 1.5 kilowatt. So this gives you information in terms of normal operation. What is the total connected load that it can have? So if you exceed this load, then you actually go into overload. But also, one thing that is worth noting is that almost all the inverters will also have short time rating. For instance, how much can it push if you have got loads like electric motors connected or motorized loads are connected to your system. So this gives you a benchmark. And apart from that, it also gives you, if you check on the charging algorithm or the instructions or steps of charging, it gives you a 3-step charging, which also below we are able to see the charging curve. It's similar if we look at the other, this one, which is the 8/10 kilowatt, and also these others also gives us the same similarities. And then apart from that, it gives you the maximum. What is the maximum AC charging current? The maximum AC charging current. So in this case, you have 40 amps, 40 amps. If we go to the other ones, we have got 100 amps, for example. We go to this one, we've got 120 amps. So this sets your boundary. You can't exceed this. If we come back again, it also gives you information on bulk charging voltages. What are the maximum that you have? If it's a flooded battery, if it's a gel battery or AGM. It also gives you information when it comes to floating charge voltage, for example. So those are some of the information. If we look at the charge mode specification, what is also important is to look at your inbuilt charger. So if we look at the 1 kilowatt inverter, we see that the maximum PV array power that you can connect is 600 watts for a 1 kilowatt inverter, and it's also 1,200 watts for a 1.5 kilowatt inverter. In terms of the voltage range, it ranges from 20 volts DC to 150 volts DC for the 1K and 30 volts to 150 volts. So this is the operating voltage that you can connect. So this sets you your boundaries of control. When it comes to the open circuit voltage, meaning when your panels are not producing anything, there's simply when you measure the voltage, if you get your panel, measure your voltage, and if you connect these panels in series, for example, they should not exceed 150 volts DC. This is similar to the other ones you see. For this type of inverter, you have got the range 60 to 500 volts DC, and also 500 volts as your maximum. But also it gives you your nominal PV voltage. So what it is in this case is that your inverter will be optimized at 240 volts for the two inverter types, 3.6 and 4.2, and also 360 volts for the 6.2. If we go for the 8 and 10, here it gives us a range of 65 to 450 volts DC, and also gives us an open circuit voltage, which is 500 volts. So this sets your first level control. You understand that I am operating within these boundaries. If we use the 1K as an example, 600 watts. I think today we've got panels, just one panel exceeding 600 volts. But if we go back in time, we had the maximum of 500, then 550, then 580, 590, and 600. So which gives you to say, for a 1K, your boundary is at 600 watts. So it's just one panel that you can connect. It can give you a maximum solar charging current of about 40 amps. But if you combine both the input AC and the solar charging current, the maximum is 80 amps. So we see that the technical specifications gives you the first level control strategy that you should look at or that you should have. Because you exceed these limits, when some systems might fail to take off. For example, if you've got very intelligent inverter systems like from day, they'll fail to take off if you get it wrong when it comes to setting up your technical specifications. But also for those that don't have that control embedded in them, they will work. It will be good installation and the system remains to work. But within a short period of time, it will fail. Either you've got failure of the inverter or you've got failure of something as part of your system. One thing that is also there, you've got the general specification, which gives you, for example, the safety certification is according to CE marking. If we look at the other ones, it's also CE marking. We look at this one, it's also CE marking. Then it gives you your operating temperature range, minus 10 degrees Celsius to 50 degrees Celsius. So, which means if you are going to build a system in a country that gets hotter than 50 degrees Celsius, then you have to make sure that the technical specification of the inverter that you are going to go for is higher than 50 degrees Celsius. But then, of course, you have situation where you buy this inverter and it will take you time for you to install. Then it also gives you the storage temperatures. If it's just not working, you have stored it. That's where you can store it without any problems. If you look at the humidity, 5% to 95% relative humidity, non-condensing, sorry for that. So you have to abide within this specification. Then if we look at these inverters that have got the grid tie operation specification, it also gives you additional information. What is the nominal output voltage? What is feed-in grid voltage? It will vary within that range. What is the feed-in grid frequency? Output current? What's the power factor above 0.99? And what is also the efficiency when you are converting DC to AC, which is about 95%. So you have got additional information. So what we are saying is that spend some time with the user manual, because it gives you your first level control strategy when you look at the technical specification and all the controls you are going to implement. Your tool to implement all these control is your user manual. So this is very important. If you are an installer, you are an engineer, you are a technician, you are a technologist, spend some time with your user manual. If you are also a customer, spend some time with the user manual, because it will give you the boundaries. You can ask questions. What have you set this? I want this. What have you put here? So that you also understand the boundaries of your system. Because sometimes there are certain inverters, they will say it cannot support inductive loads, for example. This is written in a user manual. So what it is if you connect a motor, for an example, you connect a pump, which is an inductive load, then you have a failure of this inverter. Then you say, no, my inverter is not strong. But in the user manual, it gives you the boundaries of what an inverter can support. Similarly, with a battery, it will give you all the boundaries of what it can support. So, having talked about the first level control strategy, what is next? What do we look at in the next video? So in the next video, we start to look at the first setting that set up your control. So output source priority, what is it that you want to first supply your loads? So we'll look at that. Each and every inverter has got different settings, but the three that I'm looking at, the user manuals, we'll dive into the different sections and see when do you set this and what happens, what is the sequence of control when you set up a particular output source priority. So this is the end of part 1, optimizing your residential solar PV system. So in part 2, as earlier alluded, we will now start to look at the first setting the correct output source priority. How are you going to supply your loads? For instance, or for example, when we look at if it's a backup, sometimes you don't even need to use the inverter. You might use a manual changeover switch or an automatic changeover switch. But when you use the inverter, it's important to understand. So from me, Dr. Enoch Mlenga, bye for now, and see you in the next part where we start to discuss and talk about the output source what is possible, and how do you achieve what you want for a particular output source. Thank you very much. Make sure you like our YouTube channel, subscribe, click the notification button so that you don't miss. This is very important. Invite your friends to come and listen to inverter control or residential solar PV control to optimize your system.